Okay, now we're going to look at a non-hierarchical clustering method, and this is called k-means clustering. So here we start with a value for k. So we have to choose a value for k. We say we want 5 clusters or 6 clusters or 3 clusters or whatever. In the hierarchical method, okay, we don't have to specify that. The procedure starts with one cluster assigned to each observation, and then you start building up and combining them into finally 2 clusters. Okay, and then there are methods to go through those clusters and see which one will be best. But here we specify an x number, k number of clusters, and the starting point is that the observations are usually randomly assigned to these k clusters. So if you want 3 clusters, the database observations will be randomly divided into 3 parts, one part assigned to cluster 1, 1 to 2, and 1 to 3. So that would be the starting point. But there are some heuristical methods that we can use to make sure that the initial assignment itself is not totally random, but the observations are somewhat similar. And SAS does that. So we will not get into that. We start with choosing a number for k, and then you start partitioning the data into k clusters randomly, right? And then at each step you will compute the distance, okay, between each record in the cluster with all the centroids, and find which centroid it is closest to. So you take an observation, find the distance between itself and the cluster centroid to which it is assigned, and also itself and the centroid of all other clusters. Then whichever is the closest, you assign the record to that. If it is the same cluster as it is already assigned, then you don't have to change anything. But if it is closer to a different centroid, then you move the observation to that cluster. Okay, and you do this for each record in the cluster, in every cluster. Then once the changes have happened, you recompute the. Now some observations have been removed, some observations have been added to different clusters, so the centroids would have changed. So you recompute the centroids and then repeat, and then you keep doing this until you stop when the records don't move at all, okay, or you have achieved a certain level of low level of error within clusters. So you can set up a stopping point, and then you stop at that point. So since k is a value that we have to come up with, what would be a good starting point, good value? Is 4 good, 5 good, 6 good, or what? So usually you will try different k values and choose the one that gives us meaningful clusters. Remember, our goal is to be able to interpret the cluster. You want to be able to look at the clusters, look at the properties of the clusters, and then say, okay, this cluster seems to be kind of this group, like young millennials, or another group is suburbanites or something like that. So some defining characteristics within the cluster. So whichever k gives you clusters that are interpretable, and that would be the one that you would use. So now let's look at an example in Excel.